Hey, good morning, Joel.
Hey, morning, Ricardo. How's it going?
Good. Thanks for joining.
Yep, yeah, sounds good.
Let's give it a couple of more minutes and see if more people join, and then we can go ahead and get started.
Sounds good. I have my other co-founder here, Gonzalo.
Hello there.
Yeah.
Okay, got it. Welcome. All right, I think we can get started. Yeah, welcome, and happy to have you here and present Multi. So we want to learn more about it. So take it away.
Sounds good. Yeah, thanks for having us. Yeah, just sharing my screen now, assuming you can see it. Yeah, so hello, everyone. Thanks for taking the time. My name is João, and I'm the one of the co-founders of Multy, a cloud infrastructure tool that makes it easy to build and deploy infrastructure on any cloud. Just setting out the agenda for today, we'll first start by talking about what the problem is, what are some of the current solutions, and kind of ways that people go about this. Then we'll talk about what is Multi, just have an overview of how it works as well. We'll do a demo, and finally just talk a little bit about the roadmap and where we see it going as well. Feel free to interrupt me if there are any questions. I tend to speak quite quickly, but just interrupt me. Yeah, so we'll start off with the problem. So essentially, Kubernetes has made multi-cloud for compute a lot easier. So portable containers, the fact that you can just take a container and run it almost anywhere, makes it so you can actually have your infrastructure running multi-cloud a lot simpler. However, it's not always kind of as easy for some of the rest of the infrastructure. So for Kubernetes, they're actually managed container solutions, managed Kubernetes clusters on pretty much all major cloud providers. But when it comes to the rest of the infrastructure, things get a bit trickier. So for database, for storage, for Vault, for kind of other compute solutions that aren't as portable as containers, so running on standard virtual machines or things like serverless, these things just aren't as portable as Kubernetes, which presents a set of challenges. And at the end of the day, customers want to use these managed services, and developers want to leverage them because they reduce a lot of the heavy lifting, and you don't have to kind of reinvent the wheel on a lot of these things. But at the end of the day, you don't want to be locked in to a single provider in case something happens. So some of the current solutions to run across multiple clouds, you could host your entire infrastructure on Kubernetes and host some of the rest of the infrastructure there, but that tends to be quite expensive, and it adds a layer of management as well. You can build everything through open source software and run it on virtual machines and just have it really portable as well, but that tends to be, again, hard to manage, and it can be quite expensive. Or you can just make sure that as you build infrastructure, you're building it across multiple providers, which is very, very time consuming. So that's not ideal either. So that's where Multi comes in. So it's a cloud configuration tool that allows you to build and deploy cloud agnostic infrastructure. And it essentially, at the end of the day, makes building infrastructure for multiple clouds much easier, where you can actually write once and deploy anywhere. let's look at an example here of what you currently do today to deploy, say, a virtual machine, a virtual network and a subnet across AWS and Azure. So this is Terraform code. On the left, you were using the AWS primitives to deploy a VPC and a subnet using kind of the parameters that they ask of us. And same for Azure, where we also need to add on top resource group and then some kind of add the virtual network with the specific configurations and the subnet as well. So while these resources are different, the actual core functionality is actually very similar. So this is how Multy kind of tackles this. It essentially creates an abstraction layer on top of these providers, where in the example on the left, we're deploying a Multy virtual machine. You define the name, the CIDR block, and the location. This location is then kind of converted depending on the cloud that you're running to ensure that they run, as close to each other, same country. And then finally, we have a cloud parameter where we can actually define the destination cloud for that resource. So in this case, we want to deploy a virtual network in AWS and the subnet as well. And so it will then be translated to kind of the above Terraform code where it simply gets converted to a VPC and a subnet. If we were to change that to Azure, it would instead kind of deploy a version of the Terraform code below. And as you can see, then you create kind of further resources like the Multy subnet, and you can then define the association from the virtual network from the subnet. So you actually can do those relations as well.
Question. So do you actually parse the multi-code and convert that to Terraform, or you have multiple output?
Mm-hmm. Yeah, so it's just here. So essentially, we're a Terraform provider. So we're essentially kind of an engine, and so you when you're running Terraform, you can create kind of this multi-virtual network resource. And so when you hit Terraform apply, we in the engine will then convert it into kind of cloud-specific configuration. This is just a representation of what it would look like if you were to do it by yourself. But from the user side, they would essentially just kind of run Terraform apply on the Terraform code on the left, and we would then deploy the necessary resources into the cloud providers they choose.
Sounds good. Thanks.
Yeah, so we offer our service as a Terraform provider. Our tech stack is Golang. We're using gRPC as well, and then we're also using Terraform within our engine. So in the backend, we're actually using Terraform to deploy a customer's Terraform, but that's abstracted from them. And we currently support AWS and Azure. So it's just kind of looking at the flow of how you'd interact with Multy. Essentially, you create your Terraform configuration like you would normally. You define that cloud parameter, whether you want it in AWS, Azure, or GCP. When you hit Terraform apply, that sends those requests to the Multy engine. And in the backend, we then convert it to resource-specific, kind of cloud-specific resources like S3, like Key Vault, EC2, and some other services. And so you're effectively leveraging these managed services that take care of a lot of the heavy lifting, but in a way that's then easier should you want to move clouds later on. So in the backend, how we do this, we're creating a mapping between the cloud providers. And so kind of what is the resource in AWS when you compare it to then Azure, and we're handling a lot of the differences that happen between them. So as an example, in AWS, an EC2 instance is by default private, so you can't actually access it. And in Azure, a virtual machine is public. So this essentially means that when you create an instance, you can SSH, you can HTTP directly to it. And so we're actually kind of unifying this behavior. So instead of you having to actually read through the documentation to understand what the differences are and then add some things on top to make sure that they behave the same, when you deploy a virtual network, a virtual machine through us, we're actually handling these differences, and we're making it agnostic. So for example, in a Multy virtual machine, by default it's private, so you need to add a few resources on top, Multy resources on top, to make sure that you would have access to it. And in the backend, we deploy one or more services in that cloud provider to make the behavior the same. In terms of having a bit more customization to it, we also allow for override parameters for specific use cases. So as an example, in a virtual machine, you can use the kind of the multi-virtual machine size mapping. So you can create kind of a multi-compute micro instance. But say, for instance, that you want a very specific AWS instance type that we haven't that is not in our mapping, you can then just pass it alongside your configuration as an override, and we'll let you use that specific instance type for that cloud configuration. So we'll go through a demo now. I'll just give you kind of a quick overlook before. So essentially, we're deploying kind of a standard web app infrastructure. So essentially, we have virtual machines, we have object storage, we have a vault where we store secrets from a database. So we'll deploy this on both clouds with a single kind of configuration file. And yeah, the database there sits on AWS. Kind of what we'll run through is that this infrastructure is almost all deployed except for the virtual machine within AWS, and we'll just add that easily, and we'll run the apply. So I'll just quickly walk you through the code. So if you're familiar with Terraform, we're just defining the provider here. Here we're creating the specific location that then maps to different regions within AWS and Azure, and but they're closely kind of located. This is where we'll deploy the majority of the infrastructure, so things like the networking and kind of all the resources that you'll see below. Just for the purposes of this demo, the virtual machine will only be deployed, is only deployed in Azure for now, but I'll actually add AWS a bit later on. And finally, we have the database clouds, the database cloud parameter, which is currently AWS. So just walking through this quickly, we're defining a virtual network here. This for each just goes through this array here. And so each key will be AWS or Azure. So it's essentially deploying this resource twice, changing just this cloud parameter. We're defining some subnets here where we'll place some of these resources. By default, a virtual network actually has a root table, but here, which is private, but in this case, we also want to add some kind of subnets that are public. So essentially, we're creating another root table with this destination and kind of root connection. So then we're associating kind of doing the mapping from the resources from the subnets to those root tables. Defining network security group where we're opening kind of SSH, HTTP, and HTTPS, and also port 4000 because we have a Node.js app running there. Here we can see that we're deploying a virtual machine, and in this case, this is an example of some custom configuration that you could do. So say that you have Azure as your primary cloud provider, but then you want AWS as kind of a pilot-like situation for disaster recovery. So here you can actually say, if it's Azure, I want a large instance. If it's AWS, I want a micro instance. And we're defining a few kind of standard virtual machine parameters, such as the OS and which version. We're generating a public IP. We have a script here for kind of a bash script that runs in the beginning of an instance. And yeah, again, here, the cloud provider location. This is an example of an override that you could do. So instead of using this large or micro multi abstraction, you can actually just say, I want this very specific C4 ADEX large instance in AWS.
One question, do you support spot instances or preemptible instances on the different cloud providers?
Yes, that's something we're currently looking at. We've been working with a few AI ML companies, and that's actually been quite a high request on the list to be able to run, say, on the cheapest provider, because you want something transient and cheap. So that's something that's definitely on the roadmap.
Yeah, and one thing is the cheapest provider, but also within a single provider, you also want the cheapest option, right?
Yeah,
so.
Yeah, exactly. Absolutely.
Right.
We're defining a database here as well, MySQL, so similar. We're defining a vault and some secrets. So this in Azure, it will use key vault, and for AWS, it will use parameter store. And we're just defining kind of the host name, username, and passwords. And we're defining a vault access policy that gives this specific vault it gives the virtual machine permissions to go to the vault. Some object storage for some assets, and then finally we're actually outputting the IP. So what we'll do here quickly is just add AWS here, and we'll hit Terraform apply. So essentially, what this will do is it will, since everything else is created, it's just going to create these two resources. It'll create the virtual machine here, and also give permissions for this virtual machine to access the vault. Yeah, so it will also kind of this is being used. Let me just control find. Yeah, so it will create a virtual machine and also add it to the access policy. So those will be the two things that it's doing. And it's going to take about 5 minutes to also then boot up the instance and run the init script so we can go back to it. So we can talk about roadmap as well, kind of things we see coming down the road. And this has been kind of led by developer and kind of customer interest. GCP support is high on the list. Yeah, so kind of especially for startups and with a focus on AI ML, there's definitely that request. Cloud agnostic SDK. So while we focus on infrastructure for now, there's always the question of the code and how do I get then the secrets from the vault? How do I get this specific object from my object storage? Yeah, so having kind of a way to do that in a cloud agnostic way, that's something we want to focus on as well. Cost comparison tool. So currently it's actually quite hard to go from AWS to Azure and do that cost comparison beforehand, because there's always these unknowns, unless you've used it very intimately, so you actually know where the caveats are. Even then, it's still quite tough because there's no mapping. So since we're creating this mapping, it's actually much easier for us to do this comparison. So we know that you're running on AWS. If you were to then go to Azure and run the same kind of infrastructure with the same amount of traffic, we can actually then tell you, roughly how much it would be. Would it be cheaper, like 20% cheaper, or would it be more expensive? Maybe you can run part of the infrastructure there. So that's kind of a situation that our tool makes much easier. Cross-cloud networking, so actually bridging to clouds for things like VPC peering, connecting it from one cloud to another to make that process more seamless is on the roadmap as well. And finally, looking at managed disaster recovery. So we looked at before whether you have in a main cloud you have your large compute and your infrastructure running as production, but then if you want to have a pilot light running or just kind of a skeleton of the infrastructure in a different provider, it can then be up to us. We realize that maybe part of your infrastructure is down, you want to spin that up in a different provider. So making that process more straightforward and having some managed solutions for that. And yeah, that's about it. Yeah, just a quick overview of Multy. Not sure if there are any kind of questions or yeah, would love to get your thoughts.
So on the SDK roadmap item, is that something similar to what HashiCorp has for the CDK, like where you actually call Terraform within code, and you don't call Terraform apply, but you just write your code, and then within that code you can just do something on your infrastructure?
Yeah, exactly. So instead of doing AWS the parameter store get parameter, or doing Azure Key Vault, whatever gets secrets, you're instead going to us and kind of in a similar approach to what you're doing now, is having kind of a multi Key Vault SDK, where then we go to and then you would pass kind of a cloud value as well, and we would go to that specific cloud. We know how the infrastructure was deployed, so we know how to find it, and actually getting that key. yeah, so that's kind of the thinking.
Got it. Okay, thanks.
This is Eric. I had a question in terms of like the resources that you support. Is it primarily, compute? I saw, cloud object storage. So is that something, is it all like the primary, compute storage services, or does it also include like databases and other cloud services?
Yeah, so there are some services that essentially will be, impossible to actually support, so that they're very cloud specific. However, most customers tend to use the core services.
Right.
Yeah, so yes, supporting things from from storage objects, so for something like S3 to RDS to Vault. Yeah, that's already quite a lot of ground covered in terms of what most infrastructures tend to use. And that's not to say that you couldn't use some of these more managed services, but if you can have 80% of your infrastructure in a way that's cloud agnostic, and then you have SageMaker running in AWS for a specific reason, that still makes your infrastructure significantly more portable than if you were just kind of deploying it directly to that specific provider.
Right. Okay. And I was just curious because there's also like key management services. So I was wondering if Multy had already, incorporated that, so it's agnostic, across the providers.
So we're looking to support. So what do you mean by key management service?
So I think for AWS it's like KMS.
Yeah.
And so Azure has, I think, like Key Store or something along those lines. So I was just curious if Multi provided like a single interface, if you wanted to bring your own key, that it would allow or support, something like.
Yeah, absolutely. No, so that's something we don't have at the moment, but obviously a lot of these things we're still kind of looking at and looking to support. Now it's just focusing on priority basis, kind of what do customers are most keen to have, and what tools are developers using. So it's definitely something we're looking into.
I see. Okay. Have you come across crossplay?
Yeah.
And so has that question come up where, how does Multi differ? Because I feel like there's a little bit of overlap, but I'm just curious to hear your thoughts on that.
Yeah, so we're using the at the end of the day, the cloud specific managed services where we're not really hosting any of the infrastructure. We allow you to actually use these managed services, just abstracting them in a way that then they become much more portable. So from things like from S3 to your subnet configuration, we're not hosting any of that infrastructure. We're just letting you build it in a way that becomes portable as you move from AWS to Azure to GCP.
I see. Okay. And then in that diagram that you showed in your demo, for Azure, it's the Azure icons, right, for the bottom. So it's all.
Yeah. Sorry, I just got a bit. Yeah.
No worries.
And the AWS ones look nicer as well.
Yeah. Yeah. The flat theme icons are definitely nice.
Yeah.
Okay. No, thank you so much.
Yeah.
Are there spots where it's hard to, for Multi, for the developers to maintain that abstraction between different cloud providers? Are there differences that kind of make things difficult, at least for the Multi developers?
Yeah. So there are definitely services that are more challenging than others. So it's always going to be a fine balance, whether like from like abstracting it enough so it has the similar behavior and you have the same functionality, but not abstracting away too much of that functionality. So that's definitely a challenging part that we've been dealing with. So far, we've been able to support quite a significant number of resources. And at the end of the day, when you want to be cloud agnostic, when you have that requirement because of regulation or because you just don't want to be tied to a single provider, oftentimes those very specific features are the ones that are going to then be hurtful for you longer down the road. But it's definitely a balance between abstracting enough information, but then not making too custom, and having things like the overrides as well, or you can even sometimes use the actual Terraform primitives and resources on top of the Multi resources. That gives quite a lot of flexibility at the end of the day.
That makes a lot of sense.
This is Eric. Sorry, go ahead.
No, go ahead.
Sorry, I was just going to confirm.
We have a lot of questions. So in terms of Kubernetes, so you have different Kubernetes distributions or offerings from the different cloud providers. You have EKS, you have GKE, you have AKS. Are you thinking about providing some common solution for those, or that's not on the roadmap yet?
Yeah, so we have a current implementation at the moment. It's still early days. Obviously, it's an extremely popular service to use. So currently, we're using kind of leveraging EKS and AKS and allowing you to deploy kind of a cluster and node pools as well. But yeah, it's going to be challenging. There's obviously a lot of tooling out there currently that they'll actually benefit us and make that process a little bit easier. But it's still early days in terms of Kubernetes because there are so many use cases and ways that people want to use it differently. Yeah, so it'll come down to kind of how customers actually want to build. But yeah, it's definitely high on the priority list.
Yeah, I mean, it can be pretty challenging because, yeah, like you said, the offerings are very different. Sometimes they have different ways of managing, they have different ways of upgrading. Yeah, so. And another question that I have is about your project. Or can you actually share a little bit on the community of your project? Is it mostly your company working on this, or are you planning to grow the community, or I think maybe that's the reason you're also applying for Sandbox in this CNCF?
Absolutely. Yeah, so the community is going to be a massive part of this, especially since we're making these abstractions. It can't really be, us kind of having an idea of what it should look like and implementing it. At the end of the day, we absolutely don't want it to be just this black box that just deploys infrastructure for you and you just nod and say yes. And we definitely want it to be an open source project with input from the community as we're building this. And we want it to be as open and kind of transparent as possible as to how we're actually implementing this down the line. So from day one, we've been open source and we're still growing. That community is obviously going to be a big part of it. We have focusing on contributors. So we've had a couple of contributors adding things like different database flavors, looking at extending kind of the virtual machine types to include compute, but also kind of memory intensive specific compute instances. So yeah, that's definitely going to be a big part of the project, and one that's kind of pivotal to, as we grow, kind of get continuous feedback from developers. Otherwise, we'll just kind of building this product with an image of what it should look like in our heads, but then it doesn't really meet reality because at the end of the day, cloud is used by many different ways.
Got it. Thanks.
This is Eric again. I was just going to ask, is it Terraform underneath it all? I mean, that's what Multy is effectively helping create the Terraform for the respective providers.
Yeah, so kind of in this layer, we're also using Terraform to deploy it, to deploy the actual infrastructure. That's what we're using at the moment. It's just kind of faster to get up and running instead of having to rebuild it. We are running into some challenge using it because it's not really designed for this specific use case. So we'll probably at some point look to migrate off of it and do our own kind of implementation to the cloud, just because of things like state, and we have a little bit more ways of managing it. But for now, it is Terraform that we're using.
I see. Okay. So if if somebody wanted another cloud, let's say Alibaba or IBM cloud or something, added to Multy, it would be like a step up if they had a Terraform provider already existing, right?
Yeah, exactly. For now, it's quite straightforward. And so the ability of just using the provider and Terraform will sort out the rest. That's a really big bonus. And also it kind of goes with the messaging. We don't want to want to prevent you from being locked into these clouds, but then go lock yourself into us. So that's part of the open source. That's part of using Terraform. Of, if you ever want to stop using Multi, you can just export the Terraform and continue building and managing your infrastructure. So that's definitely kind of an option that we'll give to customers and developers.
Understood. Thank you.
And the other side of the community question is, do you have a roadmap in terms of your business strategy? Because, I mean, for a project to be maintainable or sustainable, I guess, you have to, you need at least an organization behind it, right? So,
Absolutely. It's that's definitely something obviously we've thought about. For now, we're focusing on product, and so building out Multi to support as many kind of use cases as possible. Currently, we're available kind of as an open source project, so you can just run it locally and it works. However, then when you go to kind of a team of developers, as you have the more need to collaborate, instead of running this engine locally, you can use instead of our managed service that makes it easier to kind of manage the project as it grows. Additionally, adding some managed features on top for things like the cost calculator, managed services for kind of disaster recovery that we mentioned, cross-cloud networking. So some of these features will then be kind of included in that paid offering. But the core service of deploying to multiple clouds, that's open source and anyone can use it to deploy.
Awesome. Perfect. Thanks. Anybody else has any more questions?
I guess for the demo, was there something else to it?
Yeah. Sorry, I just kind of got a little sidetracked in the questions, but so essentially kind of what I wanted to show is that we had this instance running before. Now we're running kind of AWS on top. This is just a web app that we spinned up just kind of to demonstrate. So this is the Azure instance that was already running, and so essentially kind of what I want to show is that where is it? So we spin this up, and this was running this using the same database. So if I want to create a user on the Azure instance, and I want to create some, so this essentially saves bookmarks some links. So if I want to then save this, I can then go to the AWS instance that I've just spinned up. I can sign in, and did I forget the password that I put? I can't believe I forgot the passwords. Let me create another user. Sorry about that. So I need to sign up. So I've created a user, and then when I want to log in, there we go. So if I want to save a link here, let me just do this again. And here, when I go to the links, I'll see that it's saved. So essentially, kind of what I wanted to show is that with the same configuration, you just add one more resource with one more with the cloud destination that you want, and essentially, you don't really need to rewrite what's here. If you think about what it would, the time that it would take you to deploy this exact infrastructure in AWS, there will be no single line of code that you can actually copy to go to Azure. And then there are things on top like resource groups, like is a virtual machine public or private? That will be quite tricky and will force you to read extensive documentation. So in here, we just make it very easy to just extend part of your infrastructure, and it just runs and it behaves exactly the same in terms of the networking, subnets, root tables, network security groups, and in terms of access as well. So that's that's what I wanted to show.
Awesome, nice. If someone wanted to recreate the database, so it's like a separate instance of the entire stack in Azure, would that be something for the near future to be able to support that?
Yeah, definitely. So, things like S3, things like object storage, things like databases, they're not as transient as a virtual machine or secrets in a vault. So yeah, definitely that's high on the priority to then make this transition a lot more seamless and being able to just change the cloud provider and have your data go from one to another. That's definitely kind of high on our list that we've had quite a number of requests for.
Awesome.
Any last questions?
Well, thank you for presenting. Excited to, see the progress in the project and keep our fingers crossed that it gets admitted into Sandbox the next time. So,
yep,
and
absolutely.
If you need any help from the tag or any advice, please feel free to reach out. We also have a Slack channel.
Yeah.
And keep chatting there if you have any concerns, questions.
Absolutely. I appreciate everyone taking the time and the questions. It's been really interesting.
Yep. All right. Thank you all. Have a great day.
Have a good day.
Thank you.
Bye.
Bye.